In a high-risk environment, a single step backward can lead to a severe accident before anyone has time to shout a warning. But when equipped with a wearable proximity sensor, that same worker is protected as the approaching machinery is instantly halted. Traditional safety models are inherently reactive, focusing on investigation only after a worker has been injured. This leaves personnel vulnerable to the fatal four hazards: falls, struck by incidents, caught in or between, and electrocution, while failing to address the cumulative physical toll of poor lifting posture and repetitive strain. We are moving toward an intelligent safety ecosystem. By combining wearable smart tags, computer vision, and proximity sensors, organizations can identify emerging risks before they result in a medical claim. Mastering the structured deployment of these tools is what allows a safety team to intercept a hazard before it ever becomes a recorded tragedy. The first step is identifying your operational blind spots. This requires distinguishing between mechanical hazards, like blind intersections where pedestrians and equipment cross paths, and physical hazards, like the ergonomic strain of improper manual handling. This diagram illustrates a computer vision monitoring system. Video streams from existing site cameras are ingested and processed by a machine learning model. This model analyzes the footage in real time to automatically detect safety violations, such as a worker entering a zone without a hard hat or high-visibility vest. Following the data flow to the right, once a non-compliance event is detected, the system sends an instant notification to the safety manager's dashboard. This allows for an immediate on-site intervention before an injury occurs. To build a complete risk profile, we integrate environmental sensors for noise and heat stress, along with audio detectors preloaded with distress keywords to recognize shouted calls for help in real time. By mapping these specific mechanical, physical, and environmental factors, we transform invisible, subjective risks into measurable data points. This 3D pyramid represents the standard hierarchy of controls. At the top is elimination, the most effective safety measure. By using heat map data from worker wearables, we can identify conflict points and physically redesign the site layout to permanently separate pedestrians from heavy machinery. At the engineering controls level, we use ultra-wideband beacons. If a worker enters a dangerous proximity zone, the sensors communicate with the equipment to automatically shut down the machinery. Administrative controls are enhanced through AI smart belts. When a worker bends or twists in a way that risks a spinal injury, the device provides a haptic vibration, acting as a real-time coach for ergonomic best practices. Finally, the foundational PPE tier is upgraded. We deploy passive exoskeletons to reduce muscle fatigue and use AI vision cameras to ensure every piece of gear is worn correctly at all times. Based on this system, which level of the hierarchy are we using when AI heat maps are used to permanently redesign a warehouse and separate traffic? The answer is elimination. Layering AI across this hierarchy creates active safeguards that ensure strict compliance with local codes of practice. A successful rollout follows a 4-phase framework. Phase 1 is discovery, which involves scanning high-risk tasks and reviewing historical injury data to determine exactly where intervention is needed most. Phase 2 is the pilot. During this period, we test the technology with a small voluntary cohort. Success here depends on privacy by design, where all collected data is strictly anonymized to build trust with the team. In Phase 3, we scale the deployment. API integrations link wearable data directly into central HR and workforce management systems, ensuring safety rules update automatically as workers change roles or locations. Finally, Phase 4 is continuous improvement. The organizational risk register is regularly updated with fresh data, ensuring safety protocols evolve as site conditions change. There is a major failure point to watch for. If management uses wearable data for punitive surveillance rather than safety coaching, the entire program will fail. This research on AI-driven distress detection proves that we can maintain privacy while increasing safety. The system uses speech recognition strictly to identify emotional distress patterns and keywords, notifying authorities without ever recording private conversations. Treating AI as a confidential coaching aid rather than a tracking tool is the single deciding factor in gaining workforce adoption. For the system to work, every level of the hierarchy must execute their specific role. The worker is responsible for wearing the device correctly and responding to the real-time haptic feedback they receive during their shift. The supervisor's role is to monitor the team dashboard and track reported near misses. They need to understand where risks are accumulating in real time. Most importantly, the supervisor must translate that dashboard data into focused 5-minute toolbox talks, providing the team with micro-learning based on the day's actual safety events. Management is obligated to audit the program for ISO 45001 compliance and ensure that data privacy protocols remain intact. Management must also be prepared to action systemic changes, such as physical site modifications, based on the aggregated alert data provided by the workforce. This ecosystem creates a continuous feedback loop. If any level of the organization stops acting on the data, the entire safety net fails. A properly deployed system delivers a measurable end state, a reduced administrative burden, lowered incident rates, and a safety culture that meets the highest regulatory standards. Maintaining this level of protection requires commitment to 5 foundational principles. Data must be used for coaching, worker feedback must be prioritized, every near miss must be recorded, privacy must be a non-negotiable right, and AI must support the human worker. Every sensor, dashboard, and proximity alert serves a single human purpose. They ensure a worker finishes their shift and returns home safely to their family. Technology provides the data and the warnings, but safety remains a human choice. Work safe, home safe.